Hello guys, welcome to Statistics Bio 7. I'm Dr. Mohanathanari. Now we are the discussing topic interpretation of autocorrelation in past statistical software. The how to analyze autocorrelation in past statistical software. The video already published in our channel. So the continuous section of the interpretation of autocorrelation for used data set in genetic and genomics genetic linkage data analysis in past statistical software. So the continuous section of the interpretations. So the introduction of the autocorrelations. The autocorrelation is a statistical method used to determine the degree of similarity between a given the time series and a lagged version of itself over successive time intervals. Its techniques is particularly valuable in genetic and genomics, especially in the genetic linkage analysis, where it helps in understanding the inheritance patterns of genetic trade over the generations. By analyzing the autocorrelation of genetic markers, researchers can identify the regions of the genomic that are co-inheritance, providing insights into the genetic linkage and the structure of genomics. The presence of significant autocorrelation at various lag can be indicated linkage disequilibrium, which is crucial for the mapping genetic traits and understanding their distribution in populations. So the interpretation of autocorrelation in genetic linkage analysis is a method used to understand the inheritance patterns of genetic traits across generation by examining the autocorrelation of genetic markers. The provide the graph show the autocorrelation functions ACF for a specific genetic marker 1 over a lag period. So the interpretation of autocorrelation graph, the graph present in the left side. The autocorrelation value are plotted against the lag with a dashed green line indicating the confidence intervals. The value outside those intervals are considered the significance. So the next one for the table interpretation in autocorrelations. The table below show the autocorrelation value for the genetic marker 1 at the different lag along with the confidence interval. So the 4 column present in the table, the lag, correlations and confidence and the significance, yes or no. So the interpretation of the table, the lag 0 and expected the autocorrelation value in 1, the indicate the perfect correlations is itself. The lag 1, the autocorrelation is 0.3629 with a confidence value of autocorrelation 0.72, the indicating a non-significant correlations. And the lag 2, the autocorrelation is minus 0.57 with a confidence value of 0.79, the indicating a non-significant correlation of lag 2. The lag 3, the autocorrelation is minus 0.78 with a confidence value of 0.88, the indicating a significant negatively correlated of lag 3. So the lag 4, the autocorrelation is 0.03 with a confidence value of 1.02, the indicate a non-significant correlation of lag 4. So the how to determine for the significant value in autocorrelations. So the determine whether the autocorrelation value are significant. We typically compare the against the confidence interval of for the autocorrelation functions ACF. In the context of the time series analysis, those intervals are often set at 95%. For autocorrelation to be significant, the value must fall outside the confidence interval range. Here are some of the steps of the determine the autocorrelation value in significant. The calculate for the standard error. The standard error of the autocorrelation at lag for a large sample size. N is approximately 1 divided by root n. If n is a large n gauge, the approximately whole well. The contrast the confidence interval, the 95% of confidence interval for the autocorrelations is approximately plus or minus 1.96 divided by root n. The compare autocorrelation value with the confidence interval. If an autocorrelation value at the given the lag fall outside the intervals, it is considered the significance. So the example calculation for the significance in autocorrelation. Assume we have a sample size of n is equal to 10, the number of generation in your data set. So the standard error calculation is equal to 1 divided by root n, the value entered to the 1 divided by root 10. N mean the total number of generations in our data set. The value of answer in standard error 0.316. The next one for the calculation, the 95% confidence interval in autocorrelations is equal to plus or minus 1.96 in standard error is equal to enter the value plus or minus 1.96 into standard error value 0.316, the value plus or minus 62. So the significant determination, if an autocorrelation value is greater than 0.62 or less than minus 0.62, it is considered the significant. If it all within the minus 0.62 to 0.62 is not considered the not significant. So the autocorrelation result, the autocorrelation analysis for the marker 1 samples, the present in the both graphical and tabular format. The autocorrelation graph illustrates the correlation of the genetic marker across the different lag. The autocorrelation value fluctuated, showing the both positive and negative correlations. Notably, at lag 0, the autocorrelation is a 1, which is expected as it represents the correlations of the marker with itself. As the lag increases, the autocorrelation value are very significantly, with notable drops into negative value at the lag 2 and lag 3. The dashed line in the graph represent the confidence interval, providing a visual representations of the statistical significance of the correlation at the lag. So in the table, the numerical value of the autocorrelation are provided along with the corresponding the confidence interval and significance determined. At lag 1, the correlation is 0.36 with a confidence value of 0.72, the indicating a non-significant correlations. Similarly, at the lag 2, the autocorrelation is a minus 0.57, which is also the non-significant. However, at the lag 3, the autocorrelation dropped to minus 0.78 with the confidence value of 0.88, indicating a significance negative correlated. This significance negative autocorrelation suggests that there is a substantial inverse the relationship at this lag, potentially indicating the linkage disequilibrium. At lag 4, the autocorrelation returns to the non-significant value of 0.03. Thus finding the highlight specific lag where the genetic markers, inheritance patterns show the significant correlations, providing the insight into the potential genetic linkage and inheritance patterns within the studied populations. So the discussion part of the autocorrelations, the autocorrelation analysis is a genetic linkages studies help in the identifying the inheritance patterns and the linkage disequilibrium between the genetic markers. In the given the analysis, we observe a significant negative autocorrelation at lag 3, suggesting that the genetic marker at this lag is significantly negatively correlated with provides the value. This indicates the potential linkage disequilibrium. The understanding those the patterns is crucial for the genetic linkages analysis as a provide insight into the how the genetic traits are inherited across the generations. The significant autocorrelations may be indicate the presence of the linked genetic markers which can be used for the mapping the genetic associated with the specific trait or disease. This information is essential for the improving the genetic mapping accuracy and advancing our the understanding of genetic and genomics. So the autocorrelation, the conclusion, the final sections. The autocorrelation analysis is genetic linkage study to help identify the inheritance patterns and the linkages disequilibrium between the genetic markers. The specific, the scientific, the significant negatively, the significant negative autocorrelations observed at lag 3 for marker 1 suggest a potential linkage, which can be further investigation to understand the genetic base of traits and improve the gene mapping effects. By leveraging autocorrelation analysis, research can uncover important genetic relationships and enhance the accuracy of genetic studies, contributing to the broader the field of the genetic and genomic research. Okay, this is a interpretation section of the autocorrelations and used for the genetic linkage dataset in past statistical software. If you any doubt on the interpretation sections, post on the comments in the comment box. I will help you, and thank you for watching this video.